Objective 2.1, Using Properties of Exponents. In Chapter 2, we're going to be looking at polynomial functions, so we're expanding on what we learned about quadratics, and we're going to be building on that to start looking at higher degree polynomials. But before we get into the actual polynomials, we want to make sure that we're very comfortable with using exponents. And so this lesson is kind of a prep lesson to get us ready to work with exponents and to refresh our memory on the properties that we're allowed to use with exponents. So our objective for this lesson is to use properties of exponents to evaluate and simplify expressions involving powers, and then also to use exponents with scientific notation to perform operations and solve real-life problems. So we start with a review of the properties for exponents. Keeping in mind that we want A and B to represent real numbers because those are our bases, and we need M and N to be integers because those are our exponents. So we're not talking about anything complicated or fancy here yet. We're not using any kinds of fractions for exponents or decimals for exponents or anything like that. We're just using integer exponents and real number bases. And so hopefully you remember most of these from Algebra 1. We've got the product of powers property, which says if I'm multiplying them together, then I can add my exponents, given that I have the same base. Then there's the power of a power property, which says if I take one power and raise it to another power, then I can just multiply the exponents together, again, keeping the same base. We have the power of a product property, which says if I have some product and raise that to a power, then I can, excuse me, I can take each factor raised to that power separately and then multiply. The negative exponent property gives me a way of rewriting if I have my base raised to a negative exponent, rewriting it so that I turn that exponent into a positive. Okay, and we need to keep in mind that when we are asked to simplify, one of the rules for simplifying is that all of our exponents need to be positive. So when we have any negative exponents like this, we'll need to use this property to rewrite. We also need to keep in mind that A cannot be 0 because 0 in the denominator would be undefined. We then have the 0 exponent property, which says any base taken to the 0 property will be equal to 1, again, as long as A is not equal to 0. And then we can do a couple of things with quotients. So the quotient of powers property says that if I have two powers in a fraction form, which technically means they're being divided, which is why we are getting a quotient, and they have the same bases again, then we can take our two exponents here and subtract them to get the result. And finally, the power of a quotient property says if I start with the fraction and then take it to an exponent that's similar to our power of product property, I can take the power of my numerator and denominator separately, again, as long as b is not equal to 0, so we don't end up with a 0 in the denominator. So all of these properties are really tools or maybe even tricks that you can use to help simplify things, to help evaluate things, and to help make the work easier. Okay, we're trying to come up with ways that will give us simplified answers in an easy, efficient way. Okay, and then the other thing in the vocabulary here is scientific notation. And it's just reminding you that in order to be in scientific notation, we want to rewrite our number in the c times 10 to the n form. Excuse me. But we have to remember that c has to be some number between 1 and 10, where 1 is included, but 10 is not. So another way of thinking of that is we need our c value to only have one digit to the left of the decimal point. Okay? And again, we just want our exponent n to be an integer. All right, so let's just put some of this into practice and refresh our memory on how to use some of these properties. So in example 1, excuse me, we are evaluating numerical expressions. So there's no variables in this. We're just trying to work out what the answer would be. Now, if we go strictly by order of operations would say that we had to figure out what 3 to the 6th is and what 3 squared is first, because exponents come before division. Then we would be able to divide it out to get an answer. Now, that will get us a correct answer, but 3 to the 6th power is going to be a large number that's going to be difficult to get, especially if we don't have a calculator. So, instead of working it out that way, we can use the properties to kind of shortcut the order of operations to make the problem easier. So, this is an example of using the quotient of powers property, which allows us to take the 3 to the 6th and the 3 squared, having the same base, and just subtract the exponents. It's always the top exponent minus the bottom, so we're going to take 6 minus 2, which means we're going to get 3 to the 4th power. And then the question I always get is, well, how do we know if we should just leave that in exponent form or if we should actually work it out? And my answer to that is you're going to use what I call sort of the 10-second rule, which basically means if you can work this out in about 10 seconds, then you need to work it out. If it's something more complicated that would take longer for you to work out by hand, then you can leave it in exponent form. So with 3 to the 4th, we can really think of it as 3 squared times 3 squared, which is just 9 times 9, that's 81. So I would say 3 to the 4th falls under the 10-second rule, and we should be able to work that out. So our final answer to this problem is 81. Now in part B, we're taking -6 times -6 to the -1 power. Now notice in this case that this exponent only affects the base right in front of it. So we're not multiplying first and then taking it to the -1. We are just taking this -6 to the -1 power. Also notice that this -6 does not have an exponent, so we automatically assume it must be a positive one if there's nothing else there. Okay, so with that in mind, we can shortcut this a little bit. Excuse me, by using our product of powers property. We can add our exponents together, so the +1 plus the -1, that's going to get us 0. And then we can use the 0 exponent property to evaluate -6 to the 0 power as just being 1. Okay, so there's a couple of examples to get you going. I want you to pause your video right now, and I want you to try these 4 problems. As you work them out, you're going to see that there are some questions off to the side here in Zaption. I want you to give me the answers that you get to these problems in that space before you move on. Okay, and then when you're ready to move on and you've answered those questions, we'll look at example 2. All right, so hopefully you've already put your answers into Zaption. Let's check them out and see how you did. So in the first case with part A, you're taking 2 cubed squared, which is a power of powers property. So we can take 3 times 2 to get 6, and then 2 to the 6th power would be 64. And again, I think that's one you can probably figure out, so you should work that one out. In part B, we have 8 cubed times 8. So if we assume that the exponent on 8 is 1, then we're taking 3 plus 1 to get 4, so 8 to the 4th power. That one's a little more complicated. So if you had left it as 8 to the 4th, you would be okay. Or if you went ahead and multiplied it out, you would get 4,096. In part C, we've got the power of a quotients property working. So both the 2 and the 3 can get cubed separately. And then 2 cubed is 8, and 3 cubed is 27, so 8 27ths is our answer. And then finally in part D, we have 1/5 to the negative 2 power. Now notice what I did here was simply take the reciprocal of my fraction to make my exponent positive. And that's a legal move to make, because if you think of what's happening, 1 is going to be raised to the negative 2 power, and 5 is going to be raised to the negative 2 power. But I don't want negative exponents. So that means that the 1 has to get moved down here to make it positive, and the 5 is going to have to get moved up here to make it positive. That's that reciprocal action that the property says we have to do. So that's going to make it 5 squared over 1 squared, which is exactly what happens in this case. Okay, so this is legal to do. If you have a fraction that's being taken to a negative exponent, you can take the reciprocal of the fraction and make it a positive exponent in order to work things out. And you end up with 25 as your final answer. All right, example 2. Now we're simplifying algebraic expressions. So now we have variables involved as well as numbers. So in this case, we have x to the 7th, y to the 4th, over x to the negative 1, y to the negative 2. Now when you're doing problems like this, we always want to keep in mind that the properties work when our bases are the same. So you can, in your mind, think about dividing up your problem into 2 sections. There's the section where the x's are the same base, and then you have this section where your y's are the same base. And you can apply the properties to each section separately in order to figure out what the answers will be. Excuse me. So if we do that, for the x base, we're going to take the 7 on top minus the negative 1 that's on the bottom. And for the y's, we're going to take the 4 on top minus the negative 2 that's on the bottom. So we're using the quotient of powers property, but we're using it twice, once for the x base and once for the y base. Then we're going to simplify. So 7 minus negative 1 is 8, and 4 minus negative 2 is 6. And that's as far as we can go. Since we're only using variables for the base, we cannot get any final answer from this. So 6 to the 8th, y to the 6th is as simplified as we can get it. Okay, what about this one? We start out with 3 x to the negative 2, y to the 4th, and that whole thing is being squared. So this is a power of product property. 3 x to the 2nd and y are all being multiplied together, so that makes it a product, and that means each of those factors can be squared individually. Don't forget to square the 3 as well as the x to the negative 2 and the y to the 4th. That's sometimes where students make a mistake, is they forget to also square the number. Okay, so you can see here we're taking each factor and squaring it, and then we can simplify that. So the 3 squared is going to become 9. And then the x to the negative 2 squared is going to become x to the negative 4. And then the y to the 4th squared is going to become y to the 8th. So we're using the power of a power property to multiply our exponents together. But now we have that x to the negative 4, which is not considered simplified yet. So we use our negative exponent property to change that into 1 over x to the positive 4. And then we can simplify. So the 9 and the y to the 8th are technically both over 1. So that puts 9 and y to the 8th in the numerator with the x to the 4th left in the denominator. And now we have a completely simplified answer. In part C, we're taking negative 2x to the 5th y cubed and taking the entire thing to the negative 2nd power. So again, we're going to start off with the power of a product property and take each factor to the negative 2 power separately. Then we can use the power of a power property and multiply exponents in our x and y terms. And then we notice that we end up with several negative exponents, so we need to take care of that with the negative exponent property. So we're going to get 1 over negative 2 squared times 1 over x to the 10th times 1 over y to the 6th. Okay, and now if we just do a little bit of simplifying, our negative 2 squared is going to become 4. And then 4 x to the 10th and y to the 6th are all going to make up the denominator, and we'll keep a 1 in our numerator. So 1 over 4 x to the 10th, y to the 6th will be our final simplified answer. Now, something to keep in mind as you're doing these, I'm showing you one particular way that you can go about simplifying, but keep in mind that the properties really do not have any particular order in which they have to be used. So unlike our order of operations that have to go a certain way, the properties do not. So if you wanted to use the property in slightly different order to get to your answer, it will probably still end up correctly. Your answer at the end should still be the same, even if you've done things a little differently to get there. All right, so why don't you give this a try? Again, pause the video for a moment while you work these out, and then answer the questions off to the side there on your Zaption. And when you have all of the questions answered, then you can continue with the video as we finish up this lesson. All right, let's check your answers. So in part A, we need to take both 2 and x squared to the 5th power. 2 to the 5th gives us 32. X squared to the 5th, I multiply the exponents and I get x to the 10th. So 32x to the 10th should be our answer for part A. In part B, I need to change the y to the negative 2 and put that into the denominator so that I end up with both the y squared and the y cubed in the denominator. And so that's going to be equal to 1 over y to the 5th. Keep in mind, if I move that y to the negative 2 out of the numerator, what's left in the numerator is still a 1. So don't forget to include that 1 in your answer. In part C, we're taking x squared, y to the 4th, all to the negative 3rd power. So we're going to use the power of a product property along with the power of powers property to get x to the negative 6 and y to the negative 12. Then we use our negative exponent property to change that into 1 over x to the 6th, y to the 12th. And finally, our x to the 4th, y to the 10th over xy cubed. If we subtract the exponents on the x base, we get x cubed. If we subtract the exponents on the y base, we get y to the 7th. and so our final answer is x cubed y to the 7th. All right, our last example here to finish this up is to use those properties in a scientific notation kind of problem. So this problem says that in 1997, Denmark had a population of 5,284,000 and a gross domestic product, which is abbreviated GDP, of $131,400,000,000. So it's asking you to estimate the per capita GDP of Denmark. So first of all, in case you're not familiar with this term, per capita simply means per person. So we're going to divide the GDP by the population to find out how much money it is per person. So when we set that up, we're going to end up having to divide 131,400,000,000 by 5,284,000. Now I don't know about you, but that does not look like a fun problem to divide, especially if I have to do it by hand. So I'm going to help myself out a little bit, and I'm going to change these really, really large numbers into scientific notation, because that's the purpose of scientific notation. It's to help us deal with really, really large numbers or really, really small numbers. So I'm going to rewrite my GDP as 1.314 times 10 to the 11th. And again, remember that we are figuring out the exponent based on how many zeros we have. Right? So in order to end up with a decimal point right there, I have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So that's where this 11 is coming from. Same thing in my denominator for population. I want my decimal point to be right there, and I had to go 1, 2, 3, 4, 5, 6 places to get there. So there's our 6. So it's about how many places you had to move to get your decimal point in this correct spot. Okay? All right, so why does that help? Because now I can split these up, just like I did before, as two factors in the numerator and the denominator, and I can take the factors that have the same base of 10, and I can use my quotient of powers property. So I can take the 11 minus 6 and end up with 10 to the 5th for the exponent part, the 10 to a power part of my scientific notation. Now I do still have 1.314 divided by 5.284. Maybe that's not great if you have to do it by hand, but it's probably still easier than dealing with all the zeros. If we divide this out, whether by hand or by calculator, we end up with about 0.249. Now, at this point, it depends on what you're being asked for an answer. If you're being asked for scientific notation, even though this looks very close to what we want, it's not quite right yet. Because remember, our definition said that our C value had to be something between 1 and 10, and this number is not. So we would have to adjust a little bit by, in essence, borrowing a 10 from here and multiplying it to here so that we get 2.49. And if we borrow a 10 from here, then we end up with 10 to the 4th power here. So if we need our answer to be in scientific notation, we need to make sure our final answer really does fit the definition of scientific notation. In this case, however, it probably makes just as much sense to have our answer be in standard form, and so that just requires us to multiply it out and get a final answer. So in standard form, we have 24,900. And so our answer is that the per capita GDP of Denmark in 1997 was almost $25,000 per person. All right, last practice problem. Go ahead and pause the video for a moment while you give this one a try. And again, you can answer the question. You need to answer the question on Zaption of what you get for this, and then we'll check your answer and finish up the lesson. All right, so we have the swarm of locusts. The swarm could contain as many as 85 million locusts per square kilometer, and it could cover an area of 1,200 square kilometers. So how many locusts are in such a swarm? In this case, we want to multiply. So the 85 million per square kilometer times 1,200 square kilometers. If we change those into scientific notation, then that's going to be 8.5 times 10 to the 7th times 1.2 times 10 to the 3rd. And then again, we can, since this is all multiplication, we can rearrange the order and we can combine the base 10 factors together and combine the decimal factors together. So taking 10 to the 7th times 10 to the 3rd means we can add our exponents and get 10 to the 10th. When we take 8.5 times 1.2, we end up with 10.2. Now again, 10.2 does not fit the definition of scientific notation. So we need to adjust. We can rewrite 10.2 as being 1.02 times 10 to the 1st, and then we can add that 10 to the other 10 to the 10th to end up with 10 to the 11th. So in scientific notation, we would say it's 1.02 times 10 to the 11th, or in standard form, that would give us 102 billion locusts. All right, so that should be the information that you need to get through Objective 2.1 practice. Complete that in your book. Make sure you're finding resources to answer your questions as they arise, and check your answers on Canvas when you are finished. I will be in town on Wednesday and we'll be seeing you then, so you can also wait until Wednesday if you have questions, and I'd be happy to answer them for you then. Okay, we will have one more lesson tomorrow on Tuesday, and then we will meet up with each other on Wednesday. And so I look forward to seeing you guys, and good luck with this lesson.